Hi and welcome to this video on grouping and pivoting data frames. Hi, I'm Raghavendra, an expert in AI, ML and data engineering. By the end of this video, you will learn how to group the data frame and perform aggregates. You will as well learn how to pivot the data frame and perform the aggregates. Let's first import the Pandas library. I'm going to use a data set that is employees.csv, which contains some observations about the employees in an organization. And I'm going to use the read_csv function of the Pandas library to import this CSV file. I'm going to import this into an EMP, which is the data frame object. emp.shape. Let's figure out what are how many rows and columns. I have 107 rows and 11 columns in this data frame. Let's take a list of all the columns. So emp.columns is going to give that. So I'm going to have employee ID, first name, last name, email, phone number, hire date, and so on. These are all the columns of the data frame. Let's now group on the department ID column. So for every department, that is employee.groupby, I specify the column name as department ID. I am using the size method. Size method is going to count the number of records in each group created by the department ID values. So here you go. In department ID 10, you have 1 record. Department ID 20, you have 2 records, 30, you have 6 records, and so on. So 50 is the department with the highest number of employees. That's what is evident there. Alternatively, instead of grouping, you still want to get a breakup of the number of rows in each department, or in every, you want to get the breakup of every category in a categorical column, you can make use of value_counts. So emp.department_ID.value_counts method is going to give you the breakup of the number of rows in each column. So you're going to have in department 50, you have 45 records, 80 you have 34 records, very similar to grouping on department ID and using the size method. So this value counts on department ID column does exactly the same thing. Next, what we are going to do is I'm subsetting my employee data frame and obtaining only the department ID as well as the salary columns. I'm specifying a list of column names within the subscript. I don't have a filter condition here. I'm just subsetting the columns. Then I say dot for subset the columns, and I'm going to group based on department ID. Then I'm going to say dot sum. The sum is going to be applied on all the numerical columns what we have. So department ID is the column on which we are grouping. Apart from that, we just have the numerical column, that is the salary column. Effectively, the sum is going to be applied on the numerical column, that is salary. So now I understand you guys got an idea of why did I subset the data frame here. Because in the absence of subsetting, if suppose the data frame has say 15 numerical columns, this sum is going to be applied on all of the numerical columns. So I might not be interested in that. So either I subset only the relevant columns here. I'm subsetting the columns to group, the columns to aggregate, and I group by on one of the columns, and I just say dot sum. So it applies sum on the numerical column, which is just the salary. So here you go. You have the sum of salaries, the total salaries in every department. Moving on further, you are going to make use of another method to perform the aggregate, that is the AGG method. So first, I'm going to take the data frame. I'm not subsetting here. I'm using a different technique to specify the aggregate function on the columns. So I'm going to say emp.groupby on department ID. I'm grouping my employee data frame on the department ID column. Dot, I'm not just specifying the aggregate function like sum or max or anything. I'm just saying dot AGG method. I pass a dictionary as an argument to that AGG method. Let's take a look at the keys and the values of the dictionary. So the keys are salary, the employee ID, the columns on which I would want to apply the aggregate. And the aggregate functions which I apply is sum is going to be applied on the salary column, and size, that is the count of the employee IDs, are going to be performed on the employee ID column. The count on the employee ID, sum on the salary column is going to be applied. So AGG function will take a dictionary as an argument, the column names as keys, the aggregate functions to be applied as values, and I can specify any column and I can specify any aggregate. So that's, in a way, I'm customizing the output of my aggregate. Here you go. So you have department ID 10, you have the total salary as this, and there is only one employee. Department ID 20, the total salary is this, and the total number of employees is 2. So if you look at this aggregated data frame, the column names are somewhat misleading. The column names comes as salary and employee ID. In fact, this column is not just the salary here. This is actually the total salary or sum of the salary of all the employees in that department. It's actually misleading. What Pandas does is it just takes the name of the column and then puts it there. It doesn't matter whether you are actually printing the column name or you are actually printing the aggregate on that column. It just gives the name. So you are just referencing the salary column, you have salary, referencing the employee ID column, employee ID. So it would be always better if we can rename those columns into meaningful names. So I take the same code over here where I'm aggregating grouping on department ID, then performing some aggregates. Then I am using a rename function to rename these columns. So rename takes a parameter that is columns, where I again supply a dictionary there. So salary is the old column name and employee ID is the old column name, which is going to act as my keys of this dictionary to the columns argument, and the new or the updated name what I want in my output, that is the sum of salary and the count of employees, I specify as the values to this dictionary. And you see a backslash over here. This is just to continue the command in the next line. So else is going to be treated as a fresh command if you don't specify the backslash there. So that's the reason for the backslash. What you see over here, let me execute it. Yep. So now you have the department IDs coming in, and for each of these department you have the sum of their salaries of the employees and the count of the employees there. Yep. So now the column names are more meaningful, unlike the before case where it was just the salary and the employee ID, which wasn't the case actually. Now I am grouping on multiple columns, not just on department ID. I'm as well grouping on department ID as well as job ID, and I am performing an aggregate on the salary column, and I'm going to rename it as sum of salary. Let me execute it. So this is going to be a very big list. So in department 10, there is going to be only one job ID and the total salary is 5,000. Department ID 20, there are 2 job IDs. Department 30, you are further expanding within every department, within every job ID, you are finding the total salary. So instead of grouping the data, I'm going to pivot this data, use a pivot table to pivot this data where I'm performing multiple groupings, right? And I'm going to just change the orientation of the output of this aggregate using pivot table. When we have multiple conditions, representing it through pivots are going to make our output more readable. So here I have the employee data frame. I'm going to run a pivot table on that data frame. Values argument, where I'll have to specify the columns on which I want to apply the aggregate, that is the salary column. Aggregate function, I am specifying the argument value as sum. I'm going to apply sum on the salary column value. Along the row indexes, I want every department ID to come up, and against every column, I want the manager ID. It could be either the job ID, whatever I want to come up, right? So I have multiple level of grouping, and for each level of grouping, I am obtaining the sum of the salary, right? So here are the manager IDs. So in department 10, within this manager, the total salary given to the employees are 5,000. So NAN values here denote that could probably be that manager ID does not belong to that department, right? It does not belong to that department. I have only 101 manager belonging to department ID 10. So likewise, if you look at 50, you have under manager 100, the total salary given to all the employees is 36400. And the total salary given to for all the employees under 120 is this. In department 50, the total salary given to employees working under manager ID 121 is 25400, right? And so on. So wherever you see an NAN here, indicate that in department 50, 101 does not exist. He doesn't work in 101. As simple as that, right? Yeah. So in this way, you're going to get a more readable data, right? And pivot outputs can be connected to a lot of visuals, right? And write heat map and so on, and you can get some meaningful inferences out of it rather than just using a bare group by on while you're grouping multiple columns. So here are the key takeaways. Group by method allows to specify columns for grouping. Size method counts the rows in every group. AGG method allows to specify the columns and the aggregate function to be applied as a key value pair. Pivot table method generates a pivot table by performing an aggregate on a numerical column. Thank you for watching this video.